so far we've done moving up and down vertically, moving to the side horizontally, and then changing our vertical scale. So the last one we're looking at is our change in the horizontal scale. So this one may take some getting used to on kind of thinking about it, because at first it's going to look like we're changing again in the vertical scale. But I'll show you an example where you can see that we're changing in the horizontal scale. So this first one, now we're saying f of x is going to equal x squared. So it's a little different than last time, but nothing too different. So now we're going to write our g of x term, which g of x equals f of 2x. So we're just going to replace it. So whenever we see x, now we're going to put 2x. So it'll be g of x equals, and it'll be 2x, because we're replacing x, but that whole value has to be squared then. So on the other ones, we're going to put 2 on the outside. This one, we're going to put 2 inside the square. So then we'll complete the table for the values. So if x is -3, -3 squared will be 9. Remember, if you're doing this in your calculator, then you're going to have to put parentheses around it. So you'd have to write it as -3 squared. That'll equal 9. Otherwise, your calculator is going to do 3 squared times negative. Okay, so it'll be 9. Then this one, we're going to have -2 squared. So it's going to equal 4. -1 squared will be 1. 0 squared, 0. And then we'll just keep on going. So then this will be 1, 4, and 9. Okay, so when we do 2x, we're going to multiply the inside number first, and then we'll square it. So -2 squared is, or negative, sorry, it'll be 2 times -3. So it'll be -6. Square that one. We're going to get 36. Okay, so then 2. So if we plug in -2. So it'll be -2 times 2, that's -4 squared. That's going to end up equaling 16. Okay, -1 times 2 be -2. Square that, it'll equal 4. And so then we'll get 0 again. And then for this one, it'll be the same as up here. 1 times 2, 2 squared is 4. 2 times 2 squared, so 4 squared is going to be 16. And then it'll be 3 times 2, 6 squared is 36. Okay, so we're going to graph both of them on here. I don't have any different colors, so you're just going to have to look at me and how I label them. So we'll graph the first one. So -3 is going to be 9. So -3, 1, 2, 3. Oh, wait. So this one's actually kind of different. The scale is a half. So -1/2, -1, -1/2, -2. So to go back to here, -3 and 9. It's actually not even on here, so we won't worry about it. So -2, 4. So we'll go to -2. That's up here at 4. Make sure I follow the right line. So -2, 4. And then -1, we have 1, 0, 0, 1, 1, 2, 4 again. So 2, 4, right there. So this one, it'll curve. So since this is a x squared, we're looking at a quadratic. So it's going to have this curve to it. Okay, the next one we're going to graph. So at -3, we're at 36. Nowhere close to being on this graph, so we won't worry about it right now. -2 is at 16. Again, nowhere close to being on the graph. But we do have -1, 4. So -1, 4. We hit 0, 0. So right down there. And 1, 4. So we're up here again. So now we can draw the rest of that. It'll hit there. Come back up. So something along those lines. So this is going to be g of x. And this will be f of x. So another way to think about this, g of x, that's going to end up equaling f of 2x. Okay, so this is how our vertical or our horizontal scaling works. If you see, we actually have the same number, y, it's just now we've changed our scale. All right, so we just finished graphing that. We're going to go into the questions before, and we'll come back and kind of talk about that a little bit more. So how does the graph of y equals g of x relate to the graph of y equals f of x? So if we're looking at this, then what we're going to find is that we end up getting the same number, but it's just going to be at a different x value. So our y values aren't changing, it's our x values and what point we end up crossing that. Because if we were to continue this scale, eventually we get to 16 and we get to 32, and we'd find that it'd be twice as close in as what it was before. So the way that I wrote this out, it says the x values for the same y values are half, or 1 over 2, the distance from x for graph g of x compared to f of x. So when we look here, what I'm saying is that when we look at these two, the distance from where we ended up getting 4 from this y value, or from this x to y compared to this x to y, when we have the same y value, that's going to end up being, this one will be half the distance as this one. And you can see it here. You have to go over 1 to get to 4 here. You have to go over 2 to get to 4 on this one. So how are the values of f related to the values of g? So for this one, we're going to then say for the same output, the input only has to be half as large, or half as big. So for the same input, or for the same output, sorry, the input only has to be 1/2 as large. So right here, when we wanted to get 4, so we'll actually look at the positives, a little bit easier to look at. So in the original equation, we had to go to 2 on the x values, our inputs, to get 4 as an output. For this one, when we had 1 as an input, which is half of 2, then we get 4 as our output. So when we get the same output, we need only half of the same input. So that's kind of what we're looking at there. So this is somewhat difficult to visualize, but I think this part here will help you. So the way that they describe it for when you're trying to figure out the horizontal difference between them is by doing this. So what you're going to do is you're going to pick an x value where you can see both of them, or where you can double or where you can half it fairly easily, and you'll get a point. So for this one, we'll take 1. So if we start at 1, then we're going to double it. So since this one is 2x, it's f of 2x. So we're going to double it first. So we're going to double 1, and we're going to move over to 2. So now we're here. Okay, so now we're just going to go from 2, and we're just going to keep on going up until we end up finding where our x value, or our y value is. So this one we're going to run into right here at 2, 4. Okay, and then we're going to go however many spaces we need to back. And so eventually we're going to run into this point here. So this point is 1, 4. So from there we can see, okay, what's the distance between these two compared to the distance from the y-axis. So between these two, it's half the distance between these two. So we can kind of use that to also graph as well. So if we actually end up erasing this line, we can use the same logic. So we know that our f of x is going to be 2, or 2x. So f of 2x. So what we can do is trace this out. So we started 1, a point that we know, double it, and then we'll go up. So once we go up, we're going to hit a point here. And if we remember, hey, it's going to be half the distance, then we can end up going half the distance between 4, our y value, or the y axis itself, and then where we are currently. So half of the distance would be right here. So if you look on here, we actually get something fairly similar. If we were to start like a half, come over, it's going to be about here is our point. And we can end up graphing it based off of that. So you can kind of see it there. but yeah, that was not a pretty one. So it's kind of difficult to get your head wrapped around it, but once you do, I think it'll make a little bit more sense. So exploratory challenge 3, I'm actually going to end up adding a chart on here to kind of show you the difference between vertical scaling and horizontal scaling. So we're going to rewrite this one out. So we now have let f of x equals x squared, and h of x is going to equal this in here. So we're just going to rewrite this out. So h of x equals, place 1/2 x wherever you see x. So 1/2 x, and it's going to be squared. Okay, so then we'll run through this again. So -3 squared is going to be 9, 4, 1, 0, 1, 4, 9. And then this one here, we're going to look at again and change it. So we're going to do -3 times 1/2, so it's going to be 1.5, and then we'll square that. So we get 2.25. And then this will be -2 times 1/2, it's going to be -1, so now we're at 1. -1 times 1/2 will be 0.25. 0 is going to be at 0 again, and now we're going to repeat, because now we're going to get 1 times 1/2, which can be 1/2 squared, and then 1 squared, and then 1.5 squared. So we're going to get 2.25. Okay, so then to kind of make sense about how this is different than vertical scaling, we're going to put this actually on the outside. So for vertical scaling, we'd have like a t of x. That's going to equal 1/2 times f of x. So if we were to write this out as a new equation, we'd say t of x is going to equal 1/2 times x squared. So we're going to square the x first and then multiply by 1/2. So when we look at this, we're going to do -3, square it, so it's going to give us 9 times 1/2, so it'd be 4.5. This one then would be -2 squared, it's going to be 4 times 1/2, it'll be 2. 1 would be 1 squared, 1, which would be 0.5. 0 would be 0. 1 would again be 0.5. 2 would be 2. And 3 would end up being 4.5. So the difference between the two, horizontal scaling, we're going to get to the same number. It's going to take twice as many, but we'll get to the same number. So right here, when we go from -1, we get 1, but when we get to -2, we'll also get 1. We had to double the number to get to it, but we do end up getting there. Same here. When we look at these, other than 0, we aren't going to find 1/2 on any of these. We're not going to find 2, even if we keep on going, and we won't find 4.5. This is completely changing the output value. This is keeping the output value the same. If we were to put in 1/2 or 1.5, we'd end up getting these values. It's going to keep those values the same, but it's just going to stretch them out. So we'll kind of see